Today we are going to learn how to convert between standard and vertex form of a quadratic. Now, what does standard form of a quadratic look like? Right, so basically ax squared plus bx plus c. This is our standard form. As you can see, this is an example of standard form right here. X squared minus 14x plus 27. And then vertex form has your parentheses squared. What does vertex form make it easy to do? Graph it. So why do you think I could possibly ask you to take a standard form equation and convert it into vertex? Why would I do that? Oh my gosh, so you can graph it. So you can figure out what the transformations are, right? So I will also ask you to convert from vertex back to standard. This is because sometimes it's easier to find the solutions to a quadratic in standard form, and we'll go over that later in the unit. First, I'll show you how to go from vertex to standard, because that's the easier one. Does anyone know how we would take this vertex form and go to standard? What does vertex form have that standard doesn't? Parentheses. How do we get rid of parentheses? Yes, we get rid of this square. We do the operation. So how do we square something? How are we going to square x minus 7? Multiply it by itself. So we have x minus 7 times x minus 7. How do I multiply these two parentheses together? What do? Can I just do, x squared minus 40 or plus 49? Is that the correct answer here? Mm-mm. What do? The what?
Funnel?
Does it look like a funnel?
No, the funnel. Like you do x times x times 7?
Yes, yeah. I think you're trying to say foil.
You call it funnel.
Funnel?
That's what you called it last year.
I call it double distribute. I like to double distribute. Or teachers call it foiling. Yeah. Foil, F-O-I-L. First, outside, inside, last. Funnel? Maybe, I don't know. Maybe you misheard me. So, did I? I don't think so. So, you double distribute, I like to call it distributing, or you foil it, or you can use the box method, which higher levels don't really care for the box method. So, here, we're going to multiply x times x and get x squared, and x times negative 7 and get negative 7x, and negative 7 times x and get negative 7x, and negative 7 times negative 7 and 49. What do we then do? Yes, we combine our like terms, our negative 7x and negative 7x, and we get negative 14x. Then what? What do you think we do next? Hopefully no one's on their cell phones right now. It's way easier than you're making it right now. Yeah. Yes, you just add the two constants, 49 and negative 22. So what's 49 minus 22? The reason why I left the parentheses on so long is because sometimes, how could they make this vertex form harder? What else will there be? An A value. When do you think you deal with an A value? When do you deal with it? In this step. In these steps, I'm sorry. if I call this step 1, 2, 3, 4, and 5, what step would you do it? Yes. Sam? Step 4. Yes. You do not distribute the 2 to everything until step 4. So here is where I would distribute 2 to everything inside the parentheses. That's why I kept the parentheses on, to show you you don't deal with it until you're all done with the insides. Does that make sense? Okay. You could technically deal with it here. However, what's the trick? If I were to distribute the 2 here, do you distribute it to everything? What do you distribute it to? Just the first set of parentheses. If you distribute it to everything here, you're actually multiplying by 2 twice. You're actually multiplying by 4. So that's why I don't deal with the 2 until everything inside the parentheses has been dealt with. Okay. Does this look familiar? X squared minus 14x plus 27. Why? It is the standard form example that I have over here. Okay? So I did all of this to convert it back into standard form. Now I'm going to show you how to take this and convert it into vertex form. So that's down here. X squared minus 14x plus 27. So again, what did our vertex form have that our standard does not? Parentheses squared, right? Parentheses squared. So I need to figure out how I can get an expression squared from my standard form. So, down here. Am I boring you? If I were to look here, and I were to work backwards from what I did to this vertex form, what happens to the negative 14 in the above step? Negative 14x goes to what? Negative 7x and negative 7x, right? And that's where we got the 7 from. You did what to 14? Divided by 2. That's what you do every single time. You take your A, B, or C value, B value, and divide it in half. So here, our negative 14x divided in half is what? Negative 7. So if I were to do this in a box method fashion, my negative 7s would go here on the outside of the box. What goes in the top left, right here? X, right? And what goes next to it in the box, the Punnett square? X as well. So if I were to just say, okay, converting this into vertex form gives us x minus 7 squared, and I were to actually square x minus 7, I would get x times x, which is x squared. Negative 7 times x is negative 7x. Negative 7 times x is negative 7x. What does negative 7 times negative 7 give us? Is that what was in our original equation? No. So, converting from standard to vertex form is called completing the square, because you're literally having to complete the square to figure out how to finish this vertex form. So converting x squared minus 14x plus 27 into x minus 7 squared, is that fully correct? No, because why? What's wrong? I don't have the correct what? C value. You need to figure out what number, when added to 49, would get you 27. That's why it's called completing the square. Do you really need to know why it's called completing the square? No, but I thought it's interesting to show you here. So here, what would we add to 49 to get 27? What would we add? Negative what? Where'd you get that from? Or I mean, where else have you seen this on this page? Ah, in the vertex form, the negative 22. I don't know. I don't even know where my phone is. All right. So now I'll show you how to do this without using that box method, that Punnett square. It's actually really easy once you do it. So, looking at this quadratic, we have x squared minus 6x minus 12. First thing I want to do is try to create my parentheses squared. What did I do to find what is added or subtracted from x? You take your b value and do what to it? Beautiful. You take it and you divide it by 2. So what is negative 6 divided by 2? Negative 3. So far we have x minus 3 squared. Now, we know that if I was to actually multiply x minus 3 times x minus 3, I'm actually adding in an extra number. Who knows what that extra number is? Yes, very quick thinkers. What number am I adding in? I can do it really quick if you want over here. X minus 3, x minus 3. What number would go there? 9. I'm actually adding in a 9. So, whenever I'm adding something to an equation, what do I need to make sure I do to the other side? So if I'm adding a 9 to this left-hand side, what do I also need to do to the right-hand side? Add a 9. You need to balance the equation. Make sure that both sides stay equal, right? If they don't stay equal, it's a different equation. So you're adding 9 to the right-hand side. Now, they like to tell you you're adding b divided by 2 squared. So that b divided by 2 is negative 3. Negative 3 squared is what? That's what we put on the right-hand side. I don't really like this formal way of thinking about it, b divided by 2 squared. What I ask myself is, okay, I put this negative 3 here. What's happening to the negative 3? It's being squared. That's what I put on the other side. Now, is this fully in vertex form? What's wrong with it? Yeah, but in vertex form, do we ever have numbers on both sides? No. So what do you think I need to do? Subtract 9 over. So what is negative 12 minus 9? So I have x minus 3 squared minus 21. Good. So all I did here, take your b value, divide it by 2, put it after the x, and put it in parentheses and square it. Then you ask yourself, okay, what did I do to that b value divided by 2? Well, I'm squaring it, so that's what I need to add to the other side. Then get everything on one side and you're done. This is called completing the square. You're converting from standard to vertex. Now it does get a little bit harder. What makes the second example harder than the first? Has an a value. Does anyone remember what you do if you have an a value? No. You could to solve it, but we're trying to convert to vertex form. I actually taught this last year to my geometry kids. Yeah. Do what?
Do you only multiply it into like the first thing? Or is that what you're
I think so. I think you're thinking of the right thing. What is called pulling something out? Finding the what? Ah, the greatest common factor. You pull a GCF out. Now you only need to pull the GCF out of the first two terms. So what is the GCF between the first two? 3. So you pull a 3 out. What is 3x squared divided by 3? Good. And negative 12x divided by 3? And you don't pull it out of the constant. We are only trying to pull it out of the first two, because that constant needs to be added to our constant that was added into our square in the end. So just don't worry about it. Don't worry about it yet. Now, how do I make this x squared minus 4x into an x plus or minus squared? What did I do before on the previous example? Divide what? Yeah, divide b. What's our b value? Negative 4. So you take your b value, which in this case is negative 4, and you divide it by 2, and what do you get? Negative 2.
You always divide it by 2.
Always 2. Always divide by 2. So we have 3x, and then what do I put? Minus 2 squared. Can't forget about that plus 25. However, because I'm squaring x minus 2, what number am I accidentally adding into this side? You would think that. What is happening to this negative 2? It's being, but what else is happening? Oh, it's also being multiplied by 3. So what is negative 2 squared? 4 times 3 is? So what am I actually adding in? So I need to put 12 on this side. Now formally, this is b divided by 2 squared, but then I also need to multiply by the what? The a value. So here, that's 3, and then we had negative 4 divided by 2 squared, so that ends up being 12. And then what's my last and final step? Minus 12. So, oh gosh, no.
Once you put the 3 in there, do you keep it?
Yep, so it's going to be 3x minus 2 squared, and then what is 25 minus 12? And I'm done. Did I lose anybody? It's really unfortunate that I'm coming back from maternity leave teaching you one of the hardest things to remember and understand this year. So if you're totally lost,
This is the hardest thing.
in my opinion, for some reason, if I were to go to ask all my students from last year, everything that, so individually ask them what they learned, they'll totally forget about completing the square and they won't remember how to do it. For some reason, it's very hard to stick.
I don't learn anything last year.
Well, okay. Any questions on this? I want you guys to go ahead and try now this 1 and 2. Try 1 and 2. Convert the following into vertex form. Try 1 and 2.